Good afternoon, all. Today we are going to discuss about subroutine call and return mechanism. The small topic, it is the last topic of our cat one portion. So I have already told, right? It is the prime objective of going with for functions, subroutine, procedure, or method. Method is in the name. Name is different to different programming languages, but the objective and the working mechanisms are almost the same. In Java, it is called as method. In SQL, structured query language, which you may study in DBMS, there it is called as procedure. And in C++, it is called as function. In microprocessor, we are calling it as subroutines. What is the prime objective? The prime objective is to employ the reusability. If a piece of code which is being used, you have a program with 1 lakh line, 1 lakh lines are there, there you are using 100 times, you are using a block of code which is of 150 lines. Means you can keep that 150 lines as a function separately, and those 100 times or 150 times or 1000 times you can call it, so that you can save, right? Number of lines is 150. It is called for 1000 time, means if you incorporate that in a main program, 150 into 1000 lines of repeated lines will be coming. Am I correct? 1000 means 999 times it is a repetition. Instead of that, that 150 line you keep it separately as function and call it 900, sorry, what is that, 1000 times. You can save huge volume of line of code, LOC. That is the major objective of function. Now you may not feel the difference. When you go for industry and if you write thousands of code, you will feel the difference or the impact of having functions. So in programming languages, these generic codes which will be used repeatedly have been made as libraries. If you go with Python, you have studied Python, you should have studied during your first semester. In Python, Python has more libraries. MATLAB has libraries. Java has libraries. Even C, C++, if you see, small libraries are there. Functions, predefined functions are there. Square root is there. Absolute is there. In string, if you go, string is there. Even printf, scanf are predefined functions. Printf and scanf have been defined, are defined and kept inside the header file. What's the name of the header file? stdio.h, standardio.h, like that. So while doing project, you should be very careful. If I ask the students to do a project in ML or AI or robotics, everybody will go with Python, and they use the libraries which are present in Python, and they are getting output, plotting curves, displaying that confusion matrix, and say, sir, we have completed the project. It's what is happening. But you should understand the motivation of this function and library function. They are repeatedly used on. They are repeatedly used on. And they are generic. And for a project, maybe for a capstone project or for anything, maybe for what is that, paper publication, if you use only the libraries which are present in Python, what does it mean? You have no contribution. You have not contributed anything there. Contribution is zero if you use only libraries. Those libraries defined by the developers of Python, maybe developers of MATLAB. Why I'm saying this, you should know that while doing project, if you want to do sincerely, J component or capstone, it is your choice to do a project very sincerely, and you can make it in a resume. While preparing a resume, you can proudly put that I have done. But on the other hand, if you use only, you can use the libraries. Libraries are meant for using. But 100% if you use only libraries, you can. When can you do that? For your own small project. Maybe if you do it during first year or second year, And at that time you can use as a practice as a beginner. But I used to tell I am handling AI, it has J component. I tell my students minimum 20% use your own code minimum. So you are allowed to use 75 to 80%. You are allowed to use the predefined libraries. So see the impact of libraries, impact of functions, how the functions evolve into library. You are a language developer, a compiler designer. You're going to release a programming language. So in order to make it more useful, more demand, what you will do? Commonly used, common minimum that is called commonly used functions. I have to keep it as a predefined one, so that you have to fly above that. Everybody will say, right? Eagle will fly above the cloud. Like that, the users, it is a developer side, they will give more functions. But you use only those functions for implementation. You have not contributed anything. You have to go above that, and you have to do that. You have to contribute, and you write code by your own. So we don't have J component. We am talking this. You are in third semester, most of you. So you should understand actually where some students does not know. They may be having intention to go for MS in US. When you go for MS in US, you will be in need of some papers in ML or AI. So where to start? I am taking this problem. All functions are there in the Python, and I am implementing. I am getting the output. Graphs are coming. Confusion matrix is coming. Then what? How to convert it into paper? If I convert it into paper and send this paper is rejected, what I have to do? What you have to do? You should not use only the library function. Whether you use MATLAB or Java or Python, you have to contribute something more than that, some algorithm, and you should able to contribute novel. That is called novelty. 100% you should use your code. No, that is not required. Yeah, no one can do that. Right? 100% is not possible. Should not. It is not. It is a tedious process. You have to use very common basic things. Part of your project, you can use the libraries. But if you use the same thing for all entire thing, please, you are in third semester. Now we will be having J component, and in future you will be doing the final semester, final year. Sorry, in the seventh semester or eighth semester, of course. In eighth semester you will be doing capstone project. Now you will be doing some mini projects or J component project. Some good projects you may plan and you may not know how to do. And how can I claim that I have contributed some novelty? It is my novel contribution, where, how, and so on. So this is the point. So I started with the functions, right? Functions are repeatedly used or generic usage functions are converted into libraries and kept. So what is the use of the functions? This is the function. The call and return mechanism of the functions are almost the same across all the programming languages in assembly level language program as well as high level language program. Okay. So this and all should be provided by the CPU. Call return mechanism, register protection mechanism, and argument passing convention. I can see one call. In C, all of you should have studied C, C++. So three major components are there. I will talk about two. When you study function, I will talk about two. One is function call or subroutine call or method call. One is call. Another one is definition. Definition means construction of the function. What that function has to do. Add of something you are doing means what is function call in C? I am telling C is equal to add of A comma B. Here C is equal to add of A comma B is the function call. What is function definition? Somewhere in the program, maybe in the beginning or the end. In C, both are allowed in C and C++. What you will do? You will write a function. What it has to do? The function add. What it has to do actually. So I repeat, my function call is equal to C is equal to add of A comma B. A and B are the arguments or parameters which are passed to function definition. Come to function definition. Function definition, how it will we will define int add of int x comma int y. So the value sent from A is received in x here. Value sent from B as B is received y here. In the next line, open the brace. You will write int sum is equal to x plus y, return sum. So return sum. It is returned. Here we are returning in C++. Here we are returning the value, the sum value. But if you take assembly level language program, the return instruction is must. It is not returning the value or parameter or argument or the result. It is returning the function. Function is returned. Function has to go to the main function. That subroutine has to finish, and the control should go to the main program, right? The function call will be in the main program. Once the call comes, it will come to the subroutine. Subroutine will be executed, and at the last sentence, last instruction of the subroutine will be return. Once return instruction encountered, control will go to the main function, main program will continue. In C++, return is not mandatory. I tell another one function call. Add of a comma b semicolon also valid function call. Add of a comma b. Here you will receive. How will you receive? Void add of x comma y int sum is equal to x plus y print of sum. In this piece of code, you no need to return any value. You're not returning any value, you're not returning the function. But the architecture, the compiler knows that once it encounters the brace, closed brace, control will go to the main function. Understand? In assembly level language program, in 8085 and in 8086, the syntax is return. Call is CALL, return is RUTURN. Here in this code, in this PPT, it is given as RET. RET means return. Right. This is the call and return mechanism used in function. And one more point I have to tell how it is done. I will see here both are functions, but let us assume the left hand side as a main program. But it is not main program. Both are routines. Let us assume the left hand side is main program. It is some lines are there. At one point of time, call sub underscore b is coming. While writing program in paper and pencil, you will be writing call sub underscore b. While keying in, the sub underscore b is the address. Actually, it is address, and sub underscore b is a label. I hope you remember I already talked about symbol or label in one of my classes, maybe during last week. The normal examples of labels and symbols as the loop 1, loop 2, L1, L2, like that they will be using that name. So it will give this address is the starting address of the subroutine. Here, come here. In the right hand side, see right hand side. This is the subroutine, and you can see sub B is given in this field. It is a label field. I hope you remember the label field means address 5000, 5004, 5008, and so on. You remember that example which I gave. So it will here the address will be there. Address of the first instruction of the subroutine. So the control will come here and the subroutine will be executed. At last you get return. Once return comes, control will go and it will start from the next instruction of call. How? Because the usage of because of the program counter and stack pointer. What the program counter will do? It will store the address of the next instruction. It will store the address of the next instruction. What the stack pointer will do? It will store the return address. It will store the return for each and every function call. It will store the return address. So with the help of these two, it works without any problem. So a return will be encountered. When return encountered, the program counter will give the address of the next instruction to be executed. What is that current value? It is the next instruction of the call instruction. So from that next instruction of call, next to call instruction, the main program will continue its execution as usual, sequential. Then after some time, some call will encounter. Once call is encountered, program counter will stop loading the address, and it will go to control will go to the subroutine, and subroutine will be executed, and return will come. Once return is encountered, control will go to the program counter. Program counter has the address of the next instruction to the call instruction, and the call will and the next instruction will be executed, and the thing will go on. Here, one thing I want to tell, it is related to data structures and algorithm, but I think nothing wrong. Being a computer science students, you should know this. Anyway, you will study in data structures or even in AI class, they will teach. I used to tell this in AI class also. Recursive call. Please keep this in mind. The best way to reduce the time complexity is using recursive routine. Have you studied? I don't know whether you studied or not. In divide and conquer strategy, divide and conquer. Anyone are yet to study in?
Yes, sir.
Yeah, if you use divide and conquer, that will be solved using recursive routine. When you use recursive routine, well, normal iterative method and recursive routine for a single problem, same problem, there will be a drastic change of time, reduction of time. For example, I can tell one example. For Mozart, a normal iterative method, the worst case will be n square, big O of n square. If you use divide and conquer and hence recursive routine, the complexity will be n log n. The worst case time complexity is n log n. So that n log n square to n log n is very big change of time, reduction of time. How does it happen? That I won't teach you now. You study there in that subject how what mechanism helps to reduce the time into n square to n log n. In binary search, the same thing will happen. It will reduce to from n to log n. You keep this in mind. These are all very important points. You should know as a computer student what the significance of or the impact of recursive routine, divide and conquer in the complexity of any algorithm. The point is, when it reduces the time, at the same time, space complexity will increase. Why, how, or why? I will tell. Because of the stack. You should have studied the definition of recursive routine. If I ask what is meant by recursive function, you will tell function calls itself. So repeatedly, recursively, function calls it again, 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 function is being called. So for each and every function call, as I told just now, the stack will be overloaded. Stack overflow will occur. Stack overflow is a dangerous exception. In Java, you will study exception handling. There you will study IO array index out of bound exception, IO exception. One exception is stack overflow. It is highly dangerous. It will damage the system. In many routines, they will handle this array index out of bounds exception as well as stack overflow. So stack, that's why I'm saying where the address is stored. Here you should know this address is stored. Address is stored. Which for each and every call, return address is stored. So if you have number of calls, you are using recursive routine for finding factorial. You are giving 120 factorial means it is being called for 119 times means 119 addresses will be stored and space complexity will go up. Going up doesn't matter, but it may affect the hardware. It will happen. So I can talk a lot about this. We will stop with this. So it is happening. If you try to reduce the time, slowly space complexity will go up. In some application you are trying to reduce algorithm space complexity, slowly time complexity will go. So we will be calling it as time space trade-off. Time space trade-off. You see your algorithm book or refer in the net. What is one by time space trade-off? So both will do this. When you working on and trying to reduce time complexity, slowly without your knowledge, space will go up, and so on, and vice versa. Okay, so it is about that. So you should map the subjects when you study. Minimum 3-4 subjects you have to map how. Here I am saying one word. I am saying that it will be stored in stack register. One call will be stored one address in stack. When recursive call comes in any other subject, you should understand repeatedly calling. So address more address has to be stored. So time space taken is increased. So if any question is asked in interview, you should be able to answer why the space complexity increases when you use recursive routine. Okay. So you go through this very small topic. You go through this. This is a function which I talked about. And I think it's enough. I stopped with this return values. I told about return values. But here the return is not only to return the values, it is returning the control from the subroutine to the main program, unlike C, C++ or Java. That's a major difference between high level language and assembly level language. Understand? There you will be returning means returning a value, but it is not mandatory. You can write a function and can make it work even without return statement in the function. But here all the subroutine will have return statement in the end. So it will vary instruction set. Here it is RET. In 8085 and 8086 it will be RETUR returned. So I think we can close. Today I will leave you a little earlier. I talked about the portions and how to answer and how to write the exam. It will be 3 questions, 3 into 10, 30. No divisions will be there. Only one question, 10 mark, 3 questions you have to write and upload in time. So all other things I have already explained, the portion, everything I have explained. And so we'll close with this. I am closing with this. Prepare well and perform well. I will give you the attendance link. So in the first module, all of you mark your attendance. The first module, I'm telling the numericals. Performance measure is there. There you have that some formula are there, including Amdahl's law. The second module, multiplication. 2 multiplications are there. Definitely one multiplication will be there. 100% sure. It's open secret. So practice multiplication and come. The third module, you may be asked to write a simple microprocessor snippet, not the entire program. Some 3-4 lines to demonstrate something. Maybe addition, subtraction, division, multiplication, addressing modes, instruction formats. You have to demonstrate using by writing 3 or 4 lines of microprocessor code, which we have already seen. It is there in your PPT only, and nothing more than that. I know it is not a microprocessor course, but you know assembly language. So this is the about numerical questions. May be slightly twisted that you can easily understand, but it will not be direct question. Means one question will not be like this. Explain about all the addressing modes. Like this questions will not be there. And other things I have already told. I think enough explanations have been given. Portions, all of you know. I repeat: one must first module full, second module up to modified both, third module up to subroutine call and return. Okay, those who have marked attendance, you can leave. If you want any clarifications, you can ask me. Otherwise, you can leave. Mark your attendance. Prepare well. Do well. Thank you. Thank you all.
So can you please repeat the numerical, which one you told?
Yeah, numericals, possible numericals in the first module, performance of the processor. And there you have solved some problems up to Amdahl's law. I told it is in PPT, you can see Amdahl's law problem, then some other problems also there, speed up and cycles per second and all. Instruction per cycle, cycles per instruction problem are there. So Amdahl's law and so on. That is one part. Second module, multiplication. Boole's multiplication and modified Boole's multiplication. These two are very important in the second module. Definitely one question will be there. Third module, you may be asked to write a small piece of code along with the other answer. Code means microprocessor. Maybe 4 lines, 3 lines, 4 to 5 lines maximum. That lines are there in the PPT. Just to demonstrate something. That's all. You have to map the theory with the code. That's all.
Sir?
Yes.
Sir, can we be asked about memory traffic calculation in the address modes?
No. Memory traffic calculation, we are not gone to memory. Memory is in the next module.
Okay, sir. But there were given some problems in PPT, so I asked.
No. Memory, memory is in the next module. That is what you are saying is, I think it's addressing mode.
Yes, sir. It was part of that only. Like
address modes, it is
memory traffic for 3-bit and
1 bit, 1, 2, 3. It is not bit.
Yes.
Operand, 1 operand, 2 operand,
Yes,
3
yes.
operand, or 1 address, 2 address, 3 address, 0 address also is there. You have a look. It is not numerical. It is just demonstration.
Okay, sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, sir.